Good evening dear students, welcome to GTQ session. I hope you are preparing well. In this session, first I will discuss the questions correspond to basics steady state AC circuits theorems. Now from the remaining topics question will be discussed by Naresh sir. It is a completely interactive session. I want the answers from your side. For every question I will give the hints, but I want the answer from your side. That is why all of you get ready with the pen and the paper. If necessary, use a calculator also. Okay, shall we start? Okay, just observe the question for 10 seconds, then I will continue. Just observe. Okay. For this example, देखिए जी, what is our requirement is a source current. In this example, what is our requirement is a source current. To find out the source current, what is requirement is first you have to find out equivalent resistance. First let us see what is the easy way to reduce the network. In this one, if you observe here, this in this example, this 2 and 4 both are connected in the series, and this what about this 11 and 4 both are connected in the series. Now for this example, थोड़ा ध्यान से देखो जी, 6 what about this entire combination कितना होता है इधर 6. Can I call this a delta connection? Similarly इधर भी देखिए, now combination these two resistance कितना होता है इधर 15. Can I call this a delta connection? Can you convert this delta to equivalent star? For this example, all resistance are the same 6. When resistance of equal values transformed from delta to star, but resistance value decreased by 3 times. Now from that one. For this example, these 3 elements we are converting delta to equivalent star, it is decreased by 3 times. Now similarly here also same thing, it is decreased by 3 times. Now you can simplify in easy way. For this example, how these 2 and 41 and 5 all are connected in the series. Similarly here this 2, 17 and 5 all are connected in series. Now this combination all are connected in the parallel. Now I gave all the hints. Now can you find out the complete equivalent resistance network? Simplify it. This parallel combination, this entire parallel combination connected series to 2 ohms and the 5 ohms. Now I want answer from your side, what the equivalent resistance will be? Very good, many students gave the reply, very good. Many students are giving reply, very good. Abhishek, always think as a paper is easy. You are going to attempt each and every question. ऐसा सोचिए जी, always think in positive. Don't think as a paper is difficult. Very good. Equivalent resistance कितना है जी 23 ohms. Now what is the requirement is a current, source current. Source voltage कितना है 230 by 23. Then what is I equal to 10 amperes. Very good. Many students gave reply. Very good. Okay. Come to the next question. Just read this question, I will explain. very good, very good. Jeevan, Aditya, Prasad, Yamini, Manikanta, very good. Now come to the next one. What is the requirement is the I naught. Before solving any problem, first just 5 to 10 seconds think what is the easy way to conclude the answer for that one. What is the easy way to conclude the answer for that one? Because in our network analysis, same problem you can solve by using multiple methods. मगर in the objective questions आपका target क्या है? In the less time you need the accurate answer. The less time you need the accurate answer. In that way, try to develop your thought process. देखिए, for this example, what is our target is the I naught. What is the target is the I naught. To conclude easy way in this example, simply can I use the application the KVL and KCL. First let us apply the KCL at this point. If you apply KCL at this point in this example, here the I naught is the incoming current. What about 2 amperes is the outgoing current. 2 amperes is the outgoing current. If you apply KCL at this point, what the remaining current of this one is the I naught minus 2. I naught minus 2. Then here for this example, wherever the current is entering plus, other one is a minus, other one is a minus. Now for this entire loop, now for this one, can you write the KVL equation? For this entire loop, can you develop the respect to KVL equation? If you develop the respect to KVL equation for this one, lower potential to higher potential minus 3 Vx. Now higher potential to lower potential voltage drop. Now higher potential to lower potential, what about the correspond to 2 ohm resistance? Now correspond to 2 ohm resistance, higher potential to lower potential, this entire equation is equated to 0. आपको इधर क्या चाहिए? We need the only I naught to eliminate the Vx value. To eliminate the Vx value. Now Vx is a voltage across the 2 ohm resistance. In the 2 ohm resistance, how much current circulating is the I naught minus 2. In the 2 ohm resistance, how much current circulating? I naught minus 2. Can you substitute the Vx value in this equation? Can you substitute this Vx value in this equation? Do the substitution, simplify it. Check करो जी. I give all the hints. Now I want answer from your side. जो Vx है ना, Vx value इधर put करो, simplify करो. Simplify करने से I naught निकाल सकते हैं ना? Give the answers. Very good, very good, very good. Many students given reply. Very good, very good. Very good, very good. Minus 12. Very good, very good, very good, very good. Good, 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 good. Please continue this. Very good, very good. Minus 12. Good. Come to the next one. Just read this question. Now for this example, what is our requirement is the power. Power correspond which one here? 4 ampere source. Power correspond to the 4 ampere source. Here to conclude the power, what is our requirement is the, we need the voltage across the source. We need the voltage across the source. To get the voltage across the source, can I use the application of the nodal analysis in this example? If you apply the KCL at node 1, if you apply the KCL at node 1, what about the 2 amperes is the incoming current? With respect to ground potential, what is the polarity for this one is a plus. We can write this one as what resistance of this one is a 20, outgoing current. But in this one, we have to write the relation carefully. With respect to ground potential, here also what is the polarity of this one is a plus. Plus plus subtraction. Here the again minus V2. The current of this branch depends on the V1, 0.5 V1 and as well as the V2, Now what is the respect to resistance of this one is a 5. Now equation 1 is completed. Can you repeat same thing for node 2 also? Can you repeat same thing for node 2 also? Can you repeat same thing for node 2 also? Now correspond node 2, here the 4 amperes is the incoming current, 4 amperes incoming current, here the plus subtraction outgoing current. Now V2 by 2 outgoing current. Now we are writing equation with respect to V2. Whenever we are writing equation with respect to V2, here the V2 will be the greater, V2 will be greater, plus minus addition. Now plus subtraction 5. I gave the two equations. What is our requirement is the power correspond to the current source. Can I say like this here, voltage of the current source and voltage of this one both are the same. That means voltage of this current source is the V2, voltage of the current source is the V2. By solving these equations, first can you find out V2 value? Do it. I gave all the hints. Can you solve the equations? Solve the equations, find out V2 value. Find the V2 value. Find the V2 value. Very good, very good. Many students give the power also. Very good. V2 Aditya Prasad, you are saying 40 by 3. Check kar lo ji. Check kar lo, check kar lo. Check kar lo. Many students are saying 15. I am writing your answers only. I am writing your answers only. 15. Very good, very good. कौन है ये IEEE I don't know your name. See, in the many, if you observe the previous papers, for many questions we use the application nodal analysis. क्यों बोलते in the exam they are focusing on the parallel circuits. For many questions we go for nodal analysis. क्यों बोलते they are focusing on the parallel circuits. Okay, चलिए इधर V2 is a 15. If V2 is a 15, then what is the requirement is a power. 15 into 4. 15 into 4. Power how much? 60 watts. Same na? Very good dear students, very good, very good. Just observe the question. Now Shaker, you got the V2 minus 0.5, check it out once again, G1, please think as a paper is a very easy, think like that. If you think like that, then only all your inner energies will act in positive way. Don't think as a paper is a difficult. Because right now you are in the preparation of very good. देखिए in this example what is the requirement is a V0. Now here also I am trying to use the application nodal analysis. Let us assume with respect to ground potential directly can I name this a V0. Voltage across this entire branch is a V0. Now voltage this one let us name as a V2. With respect to ground potential what is the polarity is a plus. Now node voltage for this is V3. With respect to ground potential what is the polarity is a plus. देखिए इधर potential difference between V3 and ground दोनों के बीच में potential difference कितना इधर है 12. But in this example ideal voltage source is connected with the two non-reference nodes. When the ideal voltage source connected we go for supernode technique. Then with respect to supernode technique equation is combinedly developed. With respect to the supernode technique equation combinedly developed for this first node and second node excluding voltage source 4 amperes is incoming current. And in this example one more important point is थोड़ा units के ऊपर focus करो जी. Many students get the confusion here only. Simply they write the equations by taking as a resistance. but here which one is given here? Conductance is given. Conductance is given. What is the one of the unit for the conductance is a Siemens. Now here conductance is given. Now can you write the respective equation? Now we are writing equation combinedly for the node 1 and the node 2. Node 1 and the node 2. Now correspond this one. Now we are writing equation combinedly for the node 1 and as well as the node 2. Now correspond this one, we can write this as a V2 6. What a conductance is 5. Now we got a combined equation. What is the one more equation is previously we exclude this voltage source. Wherever the positive is connected, the corresponding voltage is greater. Wherever the positive is connected, the corresponding voltage is greater. We can write this with a V2 minus V0. V2 minus V0 equal to 3 V0. Now from this one we can write this as a this V2 equal to 4 V0. Can you substitute the V2 value? Can you substitute the V2 value in this first equation? आपको इधर V3 value पता है, V3 value कितना है इधर 12, V3 is 12, V3 is 12 and you know the V2 value in terms of V0, V2 value in terms of V0. By simplifying this one, can you find out V0 value? Check it out, give the answers. Very good, very good, very good, very good. Many students give the reply, very good, very good, very good. Everyone should try. Calculation करने से आपका थोड़ा concentration बढ़ेगा, थोड़ा interesting भी आ जाएगा. Okay. Very good dear students. Many students give the answers as 1.61. I am writing your answers only 1.61. Okay. Read this question. Very good. Shruti, Sudarshan, Mehak, electrical shorts, Amisha, very good. Very good, Avinash, Hani, Rama Devi. Read this next question. Okay. Now for this example, now first let us identify the connections. To identify the connections, let us give the names. Let us give the potential at this point is A. Potential at this point is A. Now potential at this point is also A. Potential at this point is also A. Potential at this point is also A. Now we can give the any name. Potential at this point is a B. Potential at this point also B. Potential at this point also B. Here the no element is the present. Similarly, give the name as a potential at C and potential at this point is a D. If you give the names, you won't get any confusion. You can easily identify the connections. You can easily identify the connections. First observe this 12, 12 and 6. 12 and 12, one joint is connected. What about this other joint is connected? Two joints are present. That means these two are in the parallel. Similarly, this 12 and 6, one joint is connected, one more joint is connected. Now again here also two joints are present. Two joint means again these two also in the parallel. Then we can give statements as these three branches are connected in the parallel. Now these three branches replaced by single resistor. Then how to write this with a combination of these two 6. Then what is the resistance of this one is 3 ohms. Come to the other one. Similarly, if you observe carefully here, carefully observe this 12 and this 12. Now correspond 12, one end is connected to the B, okay, this 12 also connected to the B, this 12 other end is connected to the A, this 12 other end is connected to the A. That means carefully observe, this 12 and 12, this 12 and 12 also connected to the parallel, because one joint is connected here, A point. What about this B point is connected, B point is connected, this 12 and 12 both are connected to the parallel. If these two are in the parallel, then what are the equivalent resistance of this one is a 6. What about this equivalent resistance of this one is a 6. Now here correspond point A, voltage source is given, voltage source is given 120, as well as one more resistor is there. What is the one more resistor is in a 9 ohms. We can develop the simplified figure like this, we can develop simplified figure like this. But the question what is asking the power absorbed by, which one here, 4 ohm resistor, 4 ohm resistor. Now for that one to conclude the power for this one, we need the either current or voltage, either we need the current or voltage across the 4 ohm resistor. To conclude that one easy way, come to the 12 and 4, this 12 and 4 both are connected to the parallel. Carefully observe, this 12 and 4 both are connected to the parallel. Can you find out the equivalent resistance for this one? What are the equivalent resistance for this parallel combination? Equivalent for parallel combination 3 ohms. Then can I select this here? Voltage across 3 ohm resistance. Give the name for this method V3. The voltage across this 3 ohm resistance, the same voltage present for these two branches, because combination of the 12 and 4, combination 12 and 4 equivalent resistance to the 3 ohms. Can we select this? This 120 volts is connected parallel to this entire branch. To find out the V3 value, can you go for voltage division technique? For this entire branch, what total voltage is 120. Similar resistance, what is similar resistance is 3 by total resistance. Simplify can I say V3 निकाल सकते ना? Find out the V3 value. Give the answers V3. Aditya, somebody asking how they have same potential. Aditya, if there is no element is present, if no element is there, we can say potential at this one both are the same. If any element is there, we can say some voltage drop is present across the element. But in this example, no element is present. If no element present, potential at this one both are the same. Potential at this one both are the same. Reason is no element is present. No element is present. Check if you simplify this one, what is V3 equal to 40 volts. Can we say this voltage across this 3 ohms, voltage is the parallel combination, both are the same, because for the parallel combination only we got the 3 ohm resistor. Then to find out the power in the 4 ohm resistor, can like this here 40 square but the corresponding resistance is the 4. Simplify karo, by simplifying that one you get the answer. Simplified, very good, many students give the reply, very good. Some students got 40 कैसा है जी, कुछ गड़बड़ हो गया, check कर लो calculations. 400 is the correct answer, very good. Okay. IEEE, in what way assign the names? IEEE, every time remember as every element has the 2 ends, starting and finishing end. You can start from any element. In that way try to give the name for the entire network. Okay, very good. 400 watts. 400 watts, very good. Read this question. It is a MSc question, you have to read carefully. The steady state AC circuit questions you have to do little carefully. क्यों बोलते हो, in the every step you have to include the both magnitude as well as angle. Now this is a MSc question, every option you have to verify, every option you have to verify. What is the first one is in the question, what is the statement given? Choke coil. The combination of this internal resistance, now this inductance we can use what as a choke. What is the first requirement is in the question you give the choke coil resistance reactance. Okay. In the question itself this supply voltage is given, supply voltage is given and the supply current is given, and you give the statement that the choke coil connected in series to some external resistance R. In the data itself given voltage resistance also given. Can I say like this, sir? In the series circuit current the all elements are same, the series circuit current the all elements are same. For this one current is known, voltage is known. From these two first can you find out this external resistance? First can you find out the external resistance? 100 by 2, 100 by 2 equal to 50 ohms. And in the question he gave a statement, this 2 amperes current correspond 2 amperes current, he gives a power factor also, he gives the power factor also. Power factor for this entire network, what is the power factor? Is the 0.866. Anybody give the answer for this one? What is the angle, how much? Angle how much? Anybody angle? Anybody angle? Anybody angle? Okay, very good, very good. 30 degrees. Now correspond to current, what is the power factor angle? Power factor angle this means 30. Now can you find out respect to impedance value? Impedance equal to, we can write this as source voltage by corresponding source current. Source voltage by source current. In the question itself given, what is the source voltage kitna is there? 230. What about source current is there? 2 amperes. Now correspond 2 amperes in the data itself given, what is the nature of power factor is a lagging, nature of power factor is lagging. Lagging means what is the sign of the angle is a negative, the sign of the angle is a negative. If you simplify this one, if you shift this angle to the numerator, if you shift this angle numerator, what is the sign for this one is a plus 30. Now we got the impedance of the entire network is obtained, impedance of the entire network is obtained. Now can you convert this polar, can you convert this in rectangular form? Can you separate the real value and the corresponding imaginary value? If you separate the real value and imaginary value, now can you give the answers? What is the real value, imaginary value? Anybody give the answers? Give the answers. Very good, very good, very good. 30 degrees, very good. Oh, somebody give answer real value. Viraya got the 99.59. Very good. Others, anybody accepting that one? Oh, somebody give the complete answer also. Aban, very good, Aban, Basu, very good. 99.59. 99.59 plus J. What is the one more value? 57.5. Check kar lo. Is it correct? Very good, very good. Oh, many students gave reply. Very good. Somebody got 59.9. Check kar lo, ek baar check kar lo. Okay. देखिए इधर. Now in this example, what is the first requirement? Option में क्या पूछ रहे हैं आपको? First requirement the resistance of the coil. Here the जो real value है ना, this real value indicate the combination of this internal resistance and combination of this external resistance. Combination of the external resistance. That means here R plus R equal to real value कितना इधर 99.56. Now regarding R value we already concluded कितना है जी R value how much 50. R value is 50. R value is 50. Now simplify करने से can you find out R value? R value oh, it is 59. Okay. Now many students are saying this is a 59. Okay, I will write your answers, don't worry. Either simplify करने से, now what is the answer? 49.59. That means first option is the correct resistance value. What is the one more requirement? The second one is the reactance. Now regarding reactance we already concluded imaginary term. What is the imaginary term? Is the 57.5. 57.5. But the second one also correct. What is the one more requirement? One more requirement is power factor of the choke coil. What is the one more requirement? Power factor of the choke coil. We need the power factor only correspond to choke coil. For that one simply can help this here R square and the corresponding XL square. To find the power factor of the choke coil we have to include the respective internal resistance and corresponding reactance. Internal resistance just now we concluded 49.59. Anybody give the answers? Power factor, give the answers. Give the answers. Very good. Ah, 0.653. 0.653. What is the nature of power factor? Inductive means lagging. Inductive means what is the nature of power factor is a lagging. That means here the C option also correct. C option also correct. Come to last one. Last one, what is asking the reactive power? What is asking the reactive power? Now for the reactive power simply we can use the formula I square XL. I square XL. In the question itself given current value how much? 2 amperes. Current value how much? 2 amperes. Now inductive reactance we already concluded XL value. This imaginary part indicate the inductive reactance. Now 57.5. Now what is the answer given as 1000, but if you multiply these two we won't get the 1000. That means last one is the incorrect option. Last one is the incorrect option. ABC are the correct answers. Very good. S is the 230. 230. What about unit is the VAR. Exam में answers conclude करते समय try to verify the units carefully. क्यों बोलते हो? In the options they may give in terms of the VAR, they may give in terms of KVR. Observe the units carefully. Okay, very good. Read the next question. Tushar, you are asking the what is the difference between reactive power and apparent power. Tushar, apparent power means S. Okay, suppose if inductive reactive power, active power is known, we can use this formula. Here the S is the apparent power, this Q is the reactive power. For the P we can use the different names. P means we can call as a active power, true power, real power, average power, we can go for different names. And here also while solving the problems don't get confusions. In the questions simply they give statements as a find the power in the network. If the statement given is find the power in the network, by default every time we go for the respective active power only. Don't go for the reactive power and the apparent power. If specifically mentioned reactive and apparent, then only go for that inductive reactive powers or the respective apparent powers. Okay. Oh, very good. Many students are giving reply. Very good. देखिए इधर. Now for this example, first let us concentrate on the respective inductive reactance and capacitive reactances. Question में दे दिया आपको. Question में कितना है जी? ओमेगा वैल्यू how much? 1000. देखिए ओमेगा वैल्यू 1000. Now from this one देखिए इधर. First can you find respect to XL value? JXL, omega L. देखिए ओमेगा वैल्यू कितना है जी, ओमेगा वैल्यू इज 1000, क्वेश्चन में दे दिया आपको, ओमेगा वैल्यू दे दिया 1000। व्हाट अबाउट दिस इंडक्टेंस ऑफ दिस में 4 मिली हेनरी, आप इधर सिंप्लीफाई करने से व्हाट द आंसर फॉर दिस वन, J4, व्हाट द आंसर इज J4। सिमिलरली कैन यू फाइंड आउट द कैपेसिटिव रिएक्टेंस फॉर दिस वन, -jxc minus j by omega c. Now capacitance value is given 250 microfarad, 250 microfarad, but omega is the 1000. Now checked out, here also we get this as a 4, here also we get this as a 4, checked out, very good, very good. Then here in this particular example, for this particular example, now this XL is known, XC is known, but how these two are connected parallel? For this one, if you find out the equivalent impedance formula क्या है, Z1 Z2 by Z1 plus Z2, check कर लो. If you simplify this one, for this entire combination, we get the equivalent impedance is the infinite. Now infinite का meaning क्या है? We can open circuit this one, we can open circuit this one, we can open circuit this entire portion. Okay. Now how to get the equivalent impedance? Z1 Z2 by Z1 plus Z2. देखिए आपको JXL पता है, आपको minus JXC पता है. Can you do the same thing for this one also? In this one again, can you find out respective inductive reactance? Can you find out the respective inductive reactance? You find out respective inductive reactance. Omega is 1000. What about this L value given as a 500? Simplify करें तो what is the answer for this one? 500 ohms. What is the, this is the J500 XL. Can you repeat same calculation for XC also? Minus JXC minus J by omega C. Now C value is the 2 microfarad. What about this omega is 1000? Checked out. Now here also many students are saying 500. Okay, minus J 500. That means for this network also, for this network also, now these two are exactly equal. For this one, if you find out equivalent impedance for this entire combination, equivalent impedance formula क्या है? Z1 Z2 by Z1 plus Z2. Simplify करें तो, substitute करो, simplify करें तो again we get the infinite. What the meaning of infinite is the impedance infinite. How do you indicate that one? As a open circuit. Here how do you indicate this as a open circuit? That means here for this example, it is open circuited, it is also open circuited. Four, 1 and the 5. What is the requirement of the question? The question what is asking the peak current? Peak current, that means is asking the I maximum, V maximum by how this 4, 1, 5, how the 4, 1, 5 all are connected in the series. If you simplify this one, what the current of this one? 1 ampere. Because in the question given peak value of voltage, what is the maximum voltage? Maximum voltage is 10. Because the question is asking the peak value of the current, then what the current is 1 ampere. Yes, Shubham, yes, if they has the RMS value, we write the 1 by root 2. Yes, very good, very good. Go for next question. Read the question carefully. Yes, Nikhil Kumar, yes, Nikhil Kumar. Balakrishna, in the next step I will take one example for average current also. Just wait a moment. One more, I will discuss one example for that one. Yes, this ideal tank circuit. Arpit Dev, yes, the given network is ideal tank circuit, yes, resonance, ideal tank circuit. Rakesh, yes, in the previous one is the ideal tank circuit. Yes. Okay. Now for this example, what is the given as a given name of the network is the RLC series circuit. देखिए आपको इधर R वैल्यू पता है, L वैल्यू पता है, C वैल्यू पता है, but the source voltage given as a 500. Source voltage given as a 500. Now you have one statement, variable frequency. What is the requirement? At what frequency the circuit would consume? कितना जी? 30% the power consumed at the resonance. Okay. First let us see then what is the actual power consumption at resonance condition. Now correspond resonance omega naught. At resonance condition, can I select this here? Now source voltage and voltage resistor both are exactly equal. Now correspond to series resonance. The entire source voltage is goes to voltage as a resistance. देखिए क्वेश्चन में दे दिया आपको कितना है जी, सप्लाई वोल्टेज कितना है इधर 500, that come across the resistance. Can you find out the power from this one? Simply we write this as a V square by R. Now in the question resistance value is given, what resistance value is a 300. Now this is a power consumption. This is a power consumption at what condition? At resonance condition, omega naught. At resonance condition, this is a power consumption. In the question, what is statement given? We have to find out frequency such that 30% the power consumption, 30% power consumption. That means here I am writing the P dash equal to, simply I am writing as I square R. I square R. The P dash is the new power. New power how much? 30% the power at the resonance condition. Now here the I nothing but this is the current flow in the RLC circuit. Can this here I equal to XL minus XC whole square. Can I write this here? For RLC series circuit, can I write this here I equal to V by impedance. V by impedance. Impedance is the RLC circuit. P dash. Now if you substitute the respective values in this one, देखो जी, if you substitute the respective values, देखिए P dash क्वेश्चन में दे दिया आपको, P dash कितना है? 30% the power at resonance condition. 30% बोल तो 0.3. क्वेश्चन में सोर्स वोल्टेज दे दिया, कितना है? सोर्स वोल्टेज how much? 500. Now resistance value is given. What the XL means? We write this with omega L. X is a 1 by omega C. What the resistance value given as a 30. In the data itself, if you observe carefully, in the data itself inductance value is given, the capacitance value also given. In the question itself inductance value is given, capacitance value is given. Check karo ji, I give all the hints. Now by substituting respect to L value, check करो जी आप, by substituting respect to L value and C value, इधर ओमेगा निकाल सकते हैं ना, check करो, do it. Substitute respect to L value and C value, by substituting these two, can you find out the omega? Simplify it. Check करो, I give all the hints, I want answer from your side. Very good, very good. कौन है नो? Ahan, very good Ahan. Very good, very good. Others anybody? Divedi got the different answer. कौन है नो? Tripathi. RMS means we are at the Vm by root 2. Peak value बोलते maximum value. Tripathi. Peak value बोलते maximum value. RMS बोलते Vm by root 2. RMS voltage Vm by root 2. Very good. Many students are giving reply. Very good. कैलकुलेशन करना है, इधर थोड़ा ध्यान से करना है. इधर क्या होता है बोलते रूट्स फाइंड आउट करने से वी गेट द टू आंसर्स, मगर फ्रीक्वेंसी शुड बी ऑलवेज पॉजिटिव. वी कंसीडर ओनली पॉजिटिव. Check करो, many students are saying approximately 45.08. checked out, is it correct? 45.08 radians per second. check करो जी, check करो. सचिन यू गॉट 450, एक बार चेक कर लो जी सचिन, कैलकुलेशन चेक कर लो एक बार. That AC circuit questions we have to little carefully. Answers, कैलकुलेशन करना है. कौन है नो आशुतोष. It previously already concluded power बोले तो by default we go for active power. आशुतोष पावर बोले तो by default we go for active power, don't go for the apparent power, reactive power. Active power के ऊपर ही फोकस करना है. Power consumption बोल दो, it is possible only correspond resistor. Inductive reactive power, capacitive reactive power बोल दो, you have to think like that. Okay. Yes Balakrishna, because at Balakrishna at resonance condition current maximum na, current is a maximum. Balakrishna, expand करो मीना, सिंप्लीफाई करो जी, एक्सपैंड करने से कहते क्वाड्रेटिक इक्वेशन. मीना क्वाड्रेटिक इक्वेशन के लिए रूट्स फाइंड आउट करो. एल वैल्यू सी वैल्यू पता है ना, सी वैल्यू दे दिया ना मीना. In this example L value given, C value is given. ये simplify करने से you get the quadratic equation. For the quadratic equation find roots for that one. Okay. Okay, very good. Okay. Now can read this one. Read the next question. Okay. Tesla, you are not getting any ideas means its meaning is थोड़ा revisions कम है जी. If you practice more number of questions, obviously the brain will start giving the so many inputs. आप जितना प्रैक्टिस करें तो उतना बढ़िया आउटपुट आएगा. कौन है ये श्रीवास्तव. फॉर एक्टिव पावर वी कैन यूज द डिफरेंट फॉर्मुलास. श्रीवास्तव, to find out active power we can use the VI cos theta or we can use the I square R, both are the same only. Srivastava, same answer is obtained. We can go for any one or we can go like this also. One more formula is we can take the voltage across resistor by R, ऐसा भी जा सकते. We can use any formula, finally answers are same. Okay Srivastava. Okay. Now come to the given question. देखिए in this example what is the statement given? Is asking to find out Vs, that means is asking the source voltage. Now for to find out source voltage he gives some condition. What is the condition? Current in this resistance equal to 0. Current in the resistance equal to 0. With help of that condition we have to find out the source voltage. Now for this example let us give the name as a node voltage as V1, let us give node voltage as a V2. Can I select this here? When the V1 V2 both are exactly equal, then only the current will be equal to 0. When the V1 V2 both are exactly equal, then only current will be equal to 0. That means first we can give the statement as a V1 V2 both are the same. Okay, and next point. Now here the current 0 means from this one you can conclude as a this source is not contributing any current. The source is not contributing any current to this one. That's why this source will circulate current only in this portion. According to given statement, current 0 means the source not providing any current for this one. That entire current circulates in this one only. Then can I select this here? This voltage will be distributed with the first element and second element. Because of this source the current circulates only in this portion. In the question itself given no current is flowing in this one. Then here can I select this here? This voltage will be distributed with the first element and the second element. Voltage across the capacitor, can I name this one as V2? Checked out to find out V2 value, can you apply the voltage division technique? But the total voltage is 20 at angle 90. total voltage into similar impedance. What is similar impedance? Is the minus J3 by total impedance, 4 minus J3 by total impedance, 4 minus J3. For this one, can you simplify this one? Check it out. V2 equal to this 20 is the 20 at an angle 90. What about this one? We can write this one 3 at an angle minus 90. Minus J means minus 90. Now similarly in the denominator, what do you write this one? Root of 4 square plus 3 square. But the magnitude will be the 5. Can you find out the angle for this one? This tan inverse of, what do you write this one? Minus 3 by 4. I gave all the hints. By simplifying this one. From this one, can you find out the V2 value? Find the V2 value. Just now we concluded current 0 means we can say this one the V1 and V2 both are exactly equal. This V1 V2 both are exactly equal. Here also same logic. This source is not providing any current to this portion, because in the question itself given no current circulating. This source contribute current only in this portion. Again can use the same thing. The total voltage distributed first element and the second element. Can you apply the voltage division technique? V1 equal total voltage into similar impedance. What is the similar impedance of this one? The minus plus J3 by total impedance. Now regarding V2 we already calculated in this example. Anybody V2 value? जो V2 value आते ना, just substitute here. In place of V1 write the V2 value. Vs. What did it is 3 at an angle 90. Denominator write is 3 root 2. 3 root 2. What about the tan inverse of 3 by 3? 3 by 3 means what the angle for this is 45 degrees. Angle is a 45 degrees. Check करो जी. I gave all the hints. पहले क्या करो? Simplify करके V2 find out करो. जो V2 आते ना, just V2 value substitute here. Now simplify करने से we get the Vs. Substitute the V2 value here. Simplify करने से we get the Vs. Oh, very good, Aditya Prasad Sahu. Okay. Very good. Many students are giving reply. Very good. थोड़ा कैलकुलेशंस थोड़ा ध्यान से करना है. एंगल मैग्नीट्यूड दोनों इंक्लूड करना है ना. Very good. Okay. Check it out. Now many students are saying now A is the correct option. पहले V simplify करो. Simplify करने से we get the V2 value. इधर substitute करने से we can find out Vs. Okay, very good. Good. Very good. Can you read this question? Ankit Kumar, you can apply any method. But what is the need of doing taking advantage there? Your choice, Ankit Kumar. Any method you can apply, but answer should be same. Ankit Kumar. Answer should be same. Any method you can apply. Mithal, Kushbu, Mithal. Yes, any method you can apply. Your choice. कोई भी मेथड लगा सकते हैं जी, वो आपका चॉइस है. ओके, चलिए, कैन यू रीड दिस क्वेश्चन. देखिए, इन द क्वेश्चन Z3 is given, but Z3 given as a 30 plus Jx. Now reactance value is unknown. In the Z3 reactance value is unknown. Now Z1 complete information is given. देखिए Z2 also complete information is given, Z2 also complete information is given. What is asking the, he asked you to find out the X value, reactance value, जो reactance ना, you have the statement that one correspond which condition, resonance condition. At resonance current is in phase with the voltage. In phase means at resonance circuit behaves as a resistive. If the circuit behaves as resistive, then what is the imaginary part of the equivalent impedance equal to 0. Imaginary part of the equivalent impedance equal to 0. Then for this example, first can you find the respect to equivalent impedance? Equivalent impedance, we can write this with a Z3. What about these two branches are connected in the Z1, Z2 are connected in the parallel. In the data itself given, what Z3 is a 330 plus Jx. What about the Z1 is the minus J30. Now I wrote the respective values also. Now simplify करो Z equivalent को, simplify करने के बाद what do you have to do? Equate the imaginary part of the equivalent impedance equal 0. Simplify करके Z equivalent find out करो. After finding that one, equate the imaginary part. Equate the imaginary part of the equivalent impedance equal to 0. Very good, very good. Many students get reply. Very good, very good, very good. Good. Rushan, Shivam, Aditya Prasad, Hiba, Shruti, Purvi. Very good. Parveen, Ajay. Very good, very good, very good, dear students. Come on, come on. Answers, answers, answers. Equivalent impedance को simplify करो, simplify करके equate the imaginary part of the equivalent impedance equal 0. Okay. Come on, come to the next question. Hurry up, hurry up, hurry up. Tushar, it depends upon your practice. आप प्रैक्टिस थोड़ा ज़्यादा करें तो क्या होता है, धीरे धीरे आपका कैलकुलेशन स्पीड बढ़ेगा, थोड़ा कंसंट्रेशन बढ़ेगा, थोड़ा एक्यूरेसी बढ़ेगा. क्वेश्चन सॉल्व करना है. द लास्ट मोमेंट क्या करना है बोलते हो, ट्राई टू पुट द टाइम इन द गिवन टाइम. क्वेश्चंस कितना सॉल्व कर रहे हैं आप चेक कर लो, आपका कैलकुलेशन स्पीड कैसा है चेक कर लो. वेरी गुड, वेरी गुड. सी इज द करेक्ट ऑप्शन इन द प्रीवियस प्रॉब्लम. ओके, आई होप ऑल ऑफ यू गॉट ना. द सी इज द करेक्ट ऑप्शन फॉर दिस वन. सी इज द करेक्ट ऑप्शन. रीड दिस क्वेश्चन. Hurry up, fast, fast. Come to this one. Now for this one, what you give statement as a minimum number of elements are connected in series, and source voltage given and source current given. Source current given, source current angle कितना इधर minus. That means indirectly you can conclude as a given nature of circuit is a inductive circuit, lagging current, minus means lagging current. Now what is the statement given as a, you asking the current provided this reactive element reduced to how much percentage here, 50%. For given data, first can you find respect to impedance value. Impedance value what will it is simply source voltage by source current, 300 by, can I simplify like this. If you simplify this one, we get this 30 impedance value got. Now from this one, can you separate respect to real part and imaginary part? can subtract the respect to real part and imaginary part. अब इधर simplify करने से we can conclude as a real part कितना होता है जी? What about this imaginary part becomes a 15. Now come to given statement carefully. What the statement given as a, you give the statement the reactive element is reduced to 50%. Element is reduced to 50%. And the question you mentioned one statement. What is the omega equal to how much? 1. But the formula is XL is equal to omega L. XL equal to omega L. XL equal to omega L. Here what is omega equal to how much? 1. Omega 1. Now in the question you mentioned as a, the reactive element becomes 50%. If you find out the inductance value, can I write this? What about this XL value? This imaginary term indicates the XL. XL equal to 15 omega. Then what is the inductance value is how much? 15 Henry. But in the question what is the statement given? The reactive element becomes a half. That means new inductance. New inductance can I write this as a 7.5 Henry? The new reactance. Now from this one can you find new reactance value XL dash. In the question itself mentioned what omega is the 1. Omega is the 1. That means 7.5 ohms. Now new reactance is known. New reactance is known and resistance value will not change. Regarding resistance no comment is given in the question. That means resistance remains same. We are modifying the only reactive element. That means the new impedance. The new impedance of this one. The real value remains same as the previous one. Resistance is the same. What about the new reactance? New reactance how much here? 7.5. From this one can you find out the respect to impedance magnitude. After finding impedance magnitude, what is the requirement is a new current. Source voltage by corresponding impedance. In the question itself given source voltage, how much source voltage is 300. 300 by, can you find out the mod of Z magnitude? Anybody answer? Very good. 11.09. Very good. 11.09. Find the magnitude. Very good. Okay. Now read this question carefully. Yes, G1. If you need, we can find out G1. Simply we write this with the R by Z dash. If you write the R by Z dash, we get the new power factor. होना बोल तो. Question पढ़ो जी. Very good. Oh, good. Ajay, good. Valpula, very good. Ajay, very good. Now for this example, if you read the question carefully, the given input is having the fundamental frequency as well as the third harmonic. What is the given network? Which one here? RLC series circuit. In the question itself, resistance value is given. He gave one statement. Now correspond third harmonic, reactance of this L and C have the equal magnitude. What is the meaning of that one? Correspond third harmonic, circuit will be at resonance condition. because at resonance condition only we get the that inductive reactance, capacitive reactance will be equal, And the question here one more data also, this L by C ratio. What is the requirement? Then what will be the effective current? What is the total RMS current in the network? Okay. First let us come to third harmonic. Now correspond to this third harmonic. In the question he mentioned as a correspond to third harmonic. Corresponds example, correspond to this third harmonic, indirectly you can conclude as a this XL3 equal to XC3. Now what about this XL formula? General formula is we write this with a omega L, that is a general formula. But in this one what is the frequency of this one? 3 omega, because third harmonic. What about this one is we write this with 1 by 3 omega C, because we are writing correspond third harmonic frequency, If you rearrange this one, if you rearrange this expression from this one, can I write this omega square is equal to 1 by 9, we write this 1 by 9 LC. We got one relation correspond to omega square. From the given information we got one data correspond to the omega square. And one more thing, correspond third harmonic, can like this said this Z3 equal to only resistive, because circuit is at resonance condition, only resistive, in the question resistance value is given, resistance value how much? 60, then can you find out respect to third harmonic current? Third harmonic current equal to third harmonic voltage by third harmonic impedance, What third harmonic voltage, what is the peak value given how much? 120 root 2, correspond third harmonic component, what is the 180 root 2, but here we need the respect to RMS current. Now can it is peak value by root 2. Now under resonance condition, impedance is equal to only resistive. If you simplify this one, what is the current of this one? 3 amperes. Whatever the current of this one, 3 amperes. This is the current correspond third harmonic. Okay, but we need the effective current. But finally, what is the requirement of the effective current? For effective current, now let us go to fundamental. Now correspond to fundamental, let us come to first impedance. First let us focus on impedance. Now we can write this with Z equal to root of XL and omega L, what is XC is 1 by omega C whole square. If you rearrange this equation, in the question itself I mentioned, but the meaning of real value is 60. If you rearrange this equation, we can write this omega square LC. Can I substitute like this? Let us use our previous relations in this one. Now correspond given information omega square, what is the omega square equal to? Can I put like this? For this example, in place of the omega square, I am writing as 1 by 9 LC. Can you cancel these two terms? If you simplify further, check it out. Can I write this omega square and C square? I am expanding this expression. If you do the square by simplifying this one, if you do the square, check it out, we can write like this. Now again in this one here in the denominator also, again in place of omega square, can I write this as a 1 by 9 LC. In place of this omega square, write the 1 by 9 LC, as well as in the question one more relation is given, L by C equal to how much given as a 900. First try to put the in place of the omega square. In this example, in place of omega square, first put the 1 by 9 LC. Now simplify it. After simplify करने के बाद in place of the L by C put the 900. Simplify करके can you find out Z magnitude? Anybody give the answer? I give all the hints. Check करो. I give all hints. चेक करो पहले क्या करो, इन प्लेस ऑफ ओमेगा स्क्वायर पुट द 1/9 LC, देन आफ्टर क्या करो, जस्ट L/C पुट करो, L/C पुट करके सिंप्लीफाई करो, सिंप्लीफाई करने से विल गेट द कंप्लीट इंपेडेंस मैग्नीट्यूड इज ऑब्टेन्ड. दिस इंपेडेंस करस्पॉन्ड विच वन, फंडामेंटल. ये किसके लिए जी, दिस इज करस्पॉन्ड फंडामेंटल इंपेडेंस. चेक करो. Okay, very good. Okay, now Z1 is completed. Now from this one देखिए आपको फंडामेंटल का इम्पीडेंस पता है, now in the question itself fundamental voltage given. What is the fundamental voltage? Peak value how much? 400√2. Now from this impedance can you find out the respective fundamental current also? Either simplify करने से we get the I1 is how much? 4 amperes. Now I1 is completed, I3 also completed. Finally we need the effective current. Whenever the unequal frequencies are present, but general formula to find out that effective current is I1 square plus I3 square. I1 square and the I3 square. In this example I1 is known. I1 is how much? 4 amperes. What about the I3 value? What is the I3 equal to how much here? 3. Simplify करने से can you find out respective current? Check it out. The current of this is 5 amperes. Current is 5 amperes. Very good. Okay. Very good. Many students get the reply. Very good. Okay. थोड़ा steady state AC circuit से calculations ध्यान से करना है. Good. Complete all of you? Very good. Many students are given reply. Okay, shall we go to the next one? Okay. Now read this question. Come on, do it fast. Try करो. Okay, Viraya, Mayank, Ankit, Kumar, Pranav. Very good. Many students are very active. Very good. I appreciate. चेक करेंगे. प्रमित, थोड़ा क्वेश्चन ध्यान से पढ़ना है जी. प्रमित. Oh, DVR at the rate of IIT Hyderabad. Very good. You got 5 amperes. Oh, you are from IIT Hyderabad. Very good. Okay. चलिए. SS Suryansh. Correct. 5 amperes correct. Okay. Very good. Okay, chaliye. In this question, understanding the given statement is the important. देखो जी क्वेश्चन में क्या पूछ रहे हैं, this is important, this word average value, that is a very important. Here remember as a in the given question, if DC source, AC sources are both are given, if he is asking the average value, its meaning is he is asking the only DC component. Its meaning is the only DC component is asking, that you have to identify carefully. That is very important. Okay. If you need the only DC component, we can easily do the calculations. Now here one inductor is given, 2 Henry. In this one also if you observe carefully, 2 plus J 4. Now plus J means what is the meaning of this one? It is also one type of inductor. Now here also this Z is having the combination of the resistor and the inductance. Resistor how much? 2. What about the inductive reactance? Inductive reactance is the the Z hai na, the Z I am indicating separately. Now correspond Z, what resistance of this one is a 2, what about the inductive reactance of this one is a J4, inductive reactance J4. Just now we concluded average value means we need the only DC component. If you need the only DC component, DC means what is omega equal how much? 0. If omega equal 0, if you find out XL value, if you put omega 0, what is XL equal to 0? XL 0 means can I select this here? Simply indicate the inductor as a short circuit. Simply indicate the inductor as a short circuit. And we have to consider only DC source. AC source का जरूरत नहीं है. Only DC source is sufficient. AC source is not required. Because our requirement is the only average value. Now come to this one. Now this is having the combination of which element? Resistor and the inductor. It is having the combination of which element? Resistor and the inductor. Here the inductor position replaced by short circuit. क्यों बोलते हो? When omega 0 बोलते हो inductor position replaced by short circuit. Then here only resistance is the present. Resistance how much here? 2 ohms. What about the source of this one is a source voltage is a 30 volts 5. What about this inductor? This inductor also replaced by short circuit. Omega 0 inductor replaced by short circuit. Then what is the requirement is a current. In the question itself direction also mentioned. In the question direction also given. Then simply what do you write is 30 by 2 plus 5. Okay. In this model of question, this is very important. In the previous papers already given similar model in the GATE exam. Very good. Oh, somebody getting 4.2. Okay. 30 by 7. Okay. Simplify कर रहे. Okay. Good. Okay. Come to the next one. Okay. Now what is the requirement of the Thevenin's? Just read the question. Whenever you are doing the revisions correspond to theorem questions, try to work out the more number of questions correspond to Thevenin's theorem and maximum power transfer theorem. These two are very important. Okay. Pranav, thank you, Pranav. Sachin is volume okay जी, check कर लो एक बार from your side. Sachin Tiwari. Okay, let's check it out. देखो जी इधर क्या चाहिए आपको VTH. चलो इधर VTH निकालने के लिए we need a VTH with respect A and B. क्या चाहिए जी? VTH with respect A and B. Okay. Now your choice now. Go for nodal analysis, mesh analysis, कोई भी technique लगाओ. That is your choice. Okay. In this example, what I am doing here, I am trying to prefer the mesh analysis. With help of the mesh analysis, let's write the equations. I am going for the KVL. Okay. Now in this example, let us assume loop current of this is I1. What about the loop current of this one? Let us name this one I2. Okay. Now first let us see the calculations correspond to I1 and I2. Okay. Once you know about I1, I2, now we can easily conclude the respective Thevenin's. If you observe the KVL, now by KVL, that means KVL 1. In the KVL 1, how do you write this measure? Now what is the voltage for this measure? 10. Now I1 circulates in the 2, 1 and the 2. What is the total resistance is the 5 I1. Now what about this one is in the 1 ohm resistance, this I1, I2 both are in the opposite direction. Opposite means what do you write this one? -2. What about this one? Lower potential to higher potential, higher potential, voltage rise. Can you write this voltage right this side? Once I will write this one, don't worry. Now this is our I1 and this is our I2. Our requirement is VTH. Okay. Now in this example here, lower potential to higher potential voltage rise, I am writing this side 2A. Sum of voltage rise equal to sum of voltage drops. Now in this example, come to the VA relation. Come to what is the meaning of this VA. VA is the voltage as a 1 ohm resistance. VA is the voltage as a 1 ohm resistance. In the 1 ohm resistance, I1 is entering at positive terminal. I1 is entering at positive terminal. Can I like this here? 1 into I1 minus. Why minus? I2 is entering a negative terminal. I2 is entering at the negative terminal, minus 2. Now plus 10 equal to 5I1 minus I2. Rearrange करने से you get one equation. इधर rearrange कर दो, we will get the equation in terms of I1 and I2. Now this is one equation. Come to one more equation. Now for this one more equation, let us focus on loop 2. Let us focus on the loop 2. Now correspond loop 2, I2 circulates in the 1 1 1. Total resistance कितना है इधर? 3I2. Now what about this one is in this 1 ohm resistance, only one current is circulate, I1 and I2. I1 I2 both in opposite direction. Lower potential, higher potential, voltage rise. देखिए I give all the hints. Now आप solve कर सकते हैं ना, check करो जी. Equation 1 and 2 solve करके can you find out respect to I1 I2 values? Give the answers. Give the answers for I1 I2. Anybody? Anybody give the answers? I1 I2. Give the answers. Answers. Anybody I1 I2 answers? Very good, very good, very good. Saxena is saying 2.5. Is it correct? Now Saxena gave answer as a I1 is a 2.5 and I2 is a 2.5. Accepting this one, shall I proceed with these answers? 2.5, 2.5, very good. Both are 2.5. Okay, Robin Yadav, Rin Kumar, Ayush. Okay, Susmita, very good. Okay, Nikhil Kumar, Arpit Dev. Okay, very good. Many students are giving reply. Very good. Aditya Prasad Saho. Okay. देखिए इधर I1 I2 पता है आपको. Now what is our next requirement is the VTH. For VTH के लिए can write the KVL equation this side. In this example, wherever the current is entering, that is a positive, other one is a negative. Now for the first letter give the positive sign and other one is a negative sign. For VTH, first letter is a positive sign and other one is a negative sign. Then can write the respect to KVL equation. Higher potential to lower potential, voltage drop to VA. Now lower potential to higher potential, minus 2I1. Now higher potential to lower potential, VTH is equal to 0. Okay. Now for this particular example, and one more thing, one more element is there na. Okay, 1 second, one more element is there. और एक element भी है इधर. Okay. In this 1 ohm resistance, wherever current is entering, this is a plus and other one is a minus. Then we write this with minus I2 equal 0. देखिए इधर I1 I2 both are exactly equal. जब I1 I2 both are exactly equal हुआ तो can I select this set with this VA equal 0? Because VA how you are getting as I1 minus I2. That means we can say this VA equal 0. VA 0. Then I1 2.5. What about this I2 also 2.5? इधर simplify करने से then what is the VTH value? I hope you are getting the VA na. This regarding VA concluded here. What is the meaning of this VA mathematics? 1 into I1 minus I2. Previously already concluded. VA meaning is a I1 minus I2. इधर I1 I2 both are exactly equal. दोनों exactly equal हुआ तो VA value कितना होता है 0. VA value कितना होता है 0. VA 0 put करो, simplify करने से can you convert the VTH value? बोलिए answers. Very good. Okay, very. So many students gave reply. Very good. Good. Rahul Kumar, Ayush, Sushmita. Very good. Arpit Dev, Pandey, very good. Now how much VTH is a 7.5? VTH is a 7.5 volts. Okay. The theorems, especially Thevenin's theorem, maximum power transfer theorem, these two are very important. Okay. Now check karo ji. Just read this question. You can do any method, choice is yours, Rakesh. Always think such that less time accurate answer. Okay. Now let us check it out. What is the requirement of short circuit current? Here what is the requirement of the short circuit current? What is the statement short circuit and with respect to load? Short circuit बोलते this AB terminals are the short circuited. this AB terminals are short circuited. Now what is our requirement? The ISC. What is our requirement is the ISC. Okay. Now this is a ground. This is a ground, this one. This AB terminals are the short circuited. Now choice is yours to find out ISC. You can go for nodal analysis, mesh analysis, वो आपका choice है. But I am preferring the nodal analysis. I am preferring the nodal analysis. देखिए, in this example, let us name as the node 1 V1 and node voltage V2 and node voltage V3. Node voltage V3. If you observe carefully, थोड़ा ध्यान से देखो जी. In this example, potential difference between V1 and ground, potential V1 and ground, दोनों के बीच में potential difference कितना है इधर 9 volts. Potential difference कितना है इधर 9 volts. Now with respect to ground potential, polarity क्या है इधर plus. देखिए इधर this is a short circuited. Short circuit means we can say this one, this V3 equal to 0. V3 equal to 0. Then with respect to ground potential, what is the polarity of this one is a plus. In these 3 nodes, V1 is known, V3 is known, what is unknown is only V2. Then can you for the node 2, for node 2 के लिए can write the respective equation. Equation develop कर सकते ना. देखिए कैसे लिख सकते हैं इधर V2 by 6. How to write this one? V2 by 6. Whatever this one plus plus subtraction V2 minus V1. V2 minus V1 by how much here 3. Whatever this one is a V2 by 2. V2 by 2. Equal to 0. Now simplify करके पहले V2 निकाल सकते ना. Give the answers. बोलो जी, give the answers. What is the anybody V2 value? Simplify करके anybody give the answers. What is the V2 value is a? Give the answers. Give the answers for V2. Oh, very good, very good. Many students give the reply. Very good, very good. GR Studio got the answer. Your answer as V2 is a 3. Is it correct? V2 is a 3. Is it correct? Check कर लो. Is it correct? V2 3 volts. Very good, very good. V2 is a 3. Okay, V2 हो गया. Now finally target क्या है जी आपका, क्या चाहिए आपको? We need the short circuit current. देखिए short circuit current निकालने के लिए can you go for the KCL at this point? Okay. Can you go for the KCL at this point? If you apply the KCL at this point, देखो जी by KCL, इधर KCL अप्लाई करेंगे. देखिए इधर KCL अप्लाई करने के लिए पहले क्या करेंगे, IX निकालेंगे. IX means क्या लाइक दिस सर V2 by 6. देखो जी IX equal to ऐसे लिख सकते हैं ना V2 by 6. क्यों बोलते हो IX given in this branch, in this branch it is given ना. V2 वैल्यू कितना आ गया आपको 3. V2 वैल्यू कितना है जी, in the calculation we got the 3 by 6. That means what is IX equal कितना है इधर 0.5. IX आ गया आपको. ओके, अब इधर कैसे लिखेंगे, ए पॉइंट के ऊपर कैसे लिखेंगे. नाउ थोड़ा ध्यान से देखिए. नाउ फॉर दिस एग्जांपल कैन आई दिस सर करंट ऑफ दिस ब्रांच इज V2 by 2. V2 by 2 because is incoming current goes from the higher potential to lower potential. Current goes from the higher potential to lower potential. V2 by 2 incoming current. What is 6ix is also 6ix also incoming current. But what about this ISC? देखो जी ISC is outgoing current. ISC is outgoing current. देखिए आपको V2 वैल्यू पता है जी, कितना है जी V2 वैल्यू how much 3. इधर IX वैल्यू कैलकुलेट किया अभी, कितना है जी IX वैल्यू how much 0.5. इधर सिंप्लीफाई करने से कैन यू फाइंड आउट ISC वैल्यू. Check it out. What ISC is a 4.5 amperes. ISC is a 4.5 amperes. Check it out. ISC is a 4.5 amperes. ISC is a 4.5. Very good, very good, very good. Okay. Good. Many students give the reply. Very good. Viraya, Sweta, Aditya Prasad, Arpit. Aditya Prasad Sahu is very active. DVR, IIT Hyderabad. Okay, very good. Okay, shall I go for next one? 4.5. Very good. How to calculate IX? Rahul Kumar, IX is the current of this branch. Rahul Kumar थोड़ा ध्यान से देखिए, क्वेश्चन में दे दिया देखो, IX is the current of this branch. करंट कैसा निकालना है जी, आपको V2 वैल्यू पता है, रेजिस्टेंस वैल्यू पता है, V2 वैल्यू पता है, रेजिस्टेंस वैल्यू पता है. V2 वैल्यू कितना है जी, कैलकुलेशन करने से 3, रेजिस्टेंस कितना है जी 6, 3 by 6 इज 0.5. ओके राहुल, ओके राहुल कुमार. Okay, very good. Okay, come to next one. Now here again we have to do little carefully. Every option we have to verify. Just read the question, I will explain. अभिषेक कुमार फास्ट सॉल्व करने में कैलकुलेशन मिस्टेक्स होता है। अभिषेक कुमार डोंट वरी, बी पॉजिटिव, धीरे धीरे आपका कैलकुलेशन एरर्स रिड्यूस होगा। ओके, डोंट वरी। सी ऑल दिस आर हैपेंस फॉर ईच एंड एवरी स्टूडेंट, स्टार्टिंग में होता है, धीरे धीरे कम हो जाता है। डोंट वरी अभिषेक कुमार। ओके, and one more thing dear students, in the during preparation time take special care about your food habits, take special care about your sleeping habits. Every day at least 10 to 15 minutes spend the time for doing the meditation, doing the any breathing exercise. These are the very essential. क्यों बोलता our body is also one type of the complex machine. If you want to get more output from the brain, we have to give the proper exercise to the brain. These are also very important. Many students are neglecting this one. Okay, be careful about this one. Don't worry अभिषेक कुमार। देखिए आपको क्या चाहिए जी, आपको इजाज के अंदर वी थेवेनिन जेड थेवेनिन मैक्सिमम पावर। ओके चलिए फर्स्ट वी थेवेनिन फाइंड आउट करेंगे। इधर वी थेवेनिन फाइंड आउट करने के लिए फर्स्ट कैन यू डिस्कनेक्ट द लोड इंपेडेंस, कैन यू डिस्कनेक्ट द दिस लोड इंपेडेंस, रिमूव द लोड इंपेडेंस। इफ यू रिमूव द लोड इंपेडेंस, now what is our requirement? The VThevenin's 3 ohms. Now load impedance is disconnected VTH. With respect to ground potential periodic is plus subtraction. Now 58 angle 45 3. Now what is the current of this middle one is the 0. Then what is the VTH by 2 plus J10. Anybody answer for this one? VTH बोलो जी answers, समझ रहे ना। I developed KCL equation at this point. Current of this branch, middle branch में current कितना होता है 0, current कुछ भी नहीं जा रहा है, इधर current कितना है। Now VTH by 2 plus J10, हाँ सिंप्लीफाई करो, सिंप्लीफाई करने से विल गेट द VTH। Anybody yes okay, many students give reply okay. Very good okay. That means first option is correct. Many students give reply as a this VTH is satisfying, okay, very good. Now can you go for JTH? Shall we go for JTH? Shall we? Now correspond JTH. Okay, now let us go for the JTH value. To find out JTH, what is the procedure? Deactivate all the independent sources. Then after with respect to load terminals, with respect to load, we have to find out the. Now this is a 3 ohms prove and the J10. Okay. Now with respect to these 2 points, how this branch 1 and branch 2 both are kind of the parallel, can you find out the equivalent impedance? 2 plus J10, सिंप्लीफाई करो, सिंप्लीफाई करने से find out JTH value, can you find JTH value, सिंप्लीफाई करो जी। Oh, very good. That means JTH is also correct. Yes, DVR, yes, MS DVR. Very good, Abhishek Kumar, very good. That means B option also correct. देखिए आपको B option सही है तो we can eliminate one answer. कौन सा आंसर एलिमिनेट कर सकते हैं? JTH में रियल वैल्यू क्या इंडिकेट करते हैं जी? JTH में रियल वैल्यू क्या इंडिकेट करते हैं? RTH। JTH में रियल वैल्यू क्या इंडिकेट करते हैं? RTH वैल्यू कितना आ गया? 2.64, मगर इधर D ऑप्शन में देखिए RTH कितना दिया? 4.5। दैट मींस D इज द इनकरेक्ट आंसर। ओके, A हो गया, B हो गया, और क्या चाहिए आपको? मैक्सिमम पावर। और क्या चाहिए जी? मैक्सिमम पावर। ओके, नाउ लेट अस फाइंड आउट द रेस्पेक्ट टू मैक्सिमम पावर। Now to get the maximum power, देखिए in the maximum power whenever you are solving the problem, first identify cases. क्यों बोलते हो, क्लास में डिस्कस किया ना, केस 1 2 3 4 डिस्कस किया, डिफरेंट केस डिस्कस किया, मगर इधर देखिए क्वेश्चन में कुछ भी इन्फॉर्मेशन नहीं दिया, कुछ भी इन्फॉर्मेशन नहीं दिया तो बाय डिफॉल्ट वी गो फॉर दिस वन एज ए ZL इक्वल ZTH कॉन्जुगेट. कुछ भी इन्फॉर्मेशन नहीं दिया तो वी गो फॉर दिस लाइक दिस ZL इक्वल ZTH कॉन्जुगेट. In the question simply they indicate as a ZL is the only variable, indicate only ZL is a variable, we go for this condition. That means here we write this as ZL equal to, we write this as 2.64 minus j 0.72. Now this is a ZL value. In this ZL value, what is the real value indicates the RL. What the real value indicates the RL. What is the requirement maximum power? For maximum power, what is simplified formula is the, simply we write this as V square by 4 RL. V square by 4 RL. Now V means here we can take the only magnitude, only we need the magnitude is sufficient, 45.6. We can say the only magnitude here, magnitude is sufficient for that calculation. Now 45.6 whole square. Now load resistance कितना है, 2.64. 2.64 सिंप्लीफाई करने से क्या P max निकाल सकते हैं ना, P max निकाल सकते हैं ना. ओके चेक कर लो जी. 196 पॉइंट सपोर्ट कर रहे, थर्ड ऑप्शन भी सही है. थर्ड ऑप्शन कितना है जी, 196. चेक कर लो थर्ड ऑप्शन कितना है जी. आर यू गेटिंग लाइक दिस 196.91 कुछ, आर यू गेटिंग सेम आंसर. चेक कर लो एक बार. हाँ वेरी गुड डियर स्टूडेंट्स, वेरी गुड. ओके वेरी गुड. ओके चलिए. Now this is the last question. Now next it will be continued by Naresh sir. Naresh sir will explain some questions in the transients and two-port network. Okay. Now this will be last question from my side. Okay. Okay. जीवन वी हैव टू फाइंड आउट ओनली एक्टिव पावर फाइंड आउट करना है जी. जीवन जी RTH जीवन, आई एम नॉट गेटिंग योर डाउट. आप क्या पूछ रहे, सी कुछ भी इंफॉर्मेशन नहीं दिया तो वी राइट ZL इक्वल ZTH कॉन्जुगेट. आप चेक करेंगे. ओ सौम्या वेरी गुड. सौजन्या very good. Okay. चलिए. नाउ लेट अस फाइंड आउट द फर्स्ट. इधर भी क्या चाहिए आपको, पहले क्या करेंगे, VTH RTH हम शॉर्ट सर्किट करंट IX. ओके. नाउ लेट अस वेरीफाई ईच ऑप्शन. नाउ लेट अस स्टार्ट फ्रॉम द फर्स्ट वन. बट द फर्स्ट वन इज द VOC means this is one VTH. Now VTH can I like this sir, in this example this VTH is equal to what we write is 1K into IX. I hope it is visible na. I hope it is a visible. It is a 1K into IX. VTH equal to 1K means into IX. Can you find out respect to IX value first? Can you find respect to IX value? To find out IX value, can write the KVL equation this side. Lower potential to higher potential voltage rise. Now IX circulating the 1 kilo ohm resistor. Now IX. Now whatever this one, higher potential to lower potential. Whatever this one also IX, entire expression equated to 0. ये सिंप्लीफाई करके IX निकाल सकते ना. इधर IX फाइंड आउट करो. IX फाइंड आउट करने के बाद कैन यू सब्स्टिट्यूट द IX वैल्यू हियर, पुट करो. पुट करने से यू गेट द VTH. चेक करो, आई गिव ऑल द हिंट्स. पहले IX निकालो. फर्स्ट ट्राई टू फाइंड आउट IX वैल्यू. Find out IX value. Then after go for the VTH. Okay. वेरी गुड. मेनी स्टूडेंट्स आर गिविंग रिप्लाई. पहले क्या करो, IX निकालो जी. IX निकालो, पहले सिंप्लीफाई करके IX निकालो. निकालने के बाद इधर पुट करो. पुट करने से चेक करो, वी गेट VTH इज 5 volts. VTH is 5 volts. VTH is 5 volts. That means here first option is correct. But if you have the last option, in the last option ISC given as a, this ISC given as a 0, that means last option is incorrect. D option is incorrect. Now first option is correct. Now let us verify the RTH value. Before going to RTH, let us find out short circuit current. From this one you can easily conclude. If you observe the short circuit here, what is the short circuit voltage, how much here in this one? 0. But if you observe carefully here, we are getting 0 volts, but here some finite voltage is there, finite voltage is there. From this one you can conclude as it is violating the KVL, it is violating the KVL, not satisfying KVL. That means here we can conclude the Norton's equivalent circuit does not exist, Norton's equivalent circuit not exist. That means here the C option is incorrect, C option is incorrect. If you are getting Norton's equivalent circuit not exist, indirectly you can conclude as a होना बोलते RTH calculate करो, you get the RTH equal 0, RTH equal 0 only. RTH के लिए what we do here, deactivate this source, deactivate this one. Now across the load terminals assume the any source, simplify करो, simplify करने से we get the RTH equal 0, RTH equal 0. Okay. Okay, okay, okay. Okay, dear students. Okay. All of you try to do calculations very carefully in the exam. Okay, wish you all the best, and some more questions will be discussed by Naresh sir. Okay.
Good evening, dear students. Myself Naresh Yalala. I am going to discuss now the problem based on transient analysis, two-port network and magnetically coupled circuits. Okay. My colleague has, I think, completed steady state AC analysis, basics and theorems. Okay. Naresh Yalala. I am going to discuss now the problem based on transient analysis, two-port network and magnetically coupled circuits. Okay. My colleague has, I think, completed steady state AC analysis, basics and theorems. Okay. The first question is here. So please read carefully. The question is based on transient analysis. In the circuit shown in figure, Vc1 of 0 minus is equal to 6 volts, Vc2 of 0 minus is equal to 24 volts. The switch is closed at time t is equal to 0. The voltage Vc1 of t at a time t after the switch is closed is. So which one is the option for this question? Within 2 minutes give answer. Please take a snap. Option A. My voice is clear? The circuit is clear? No response from the students. The figure is clear? Yes, okay. Thank you for your response. Option A. So many students are given option A. So is this a first order circuit or second order circuit? Is a first order circuit only. So for first order circuit, the input is a DC or step input. What is the formula for this one is? Just use the final value plus initial value minus final value t power minus t by tau. That is enough. But here the two capacitors are there with initial conditions. दो capacitors है, इसके initial conditions भी हैं. So to approach, so they use आप use कर सकते, Laplace transform भी use कर सकते, without Laplace भी कर सकते. But using a Laplace transform, it will take a more and more time. In place of Laplace transform, use just formula. So final value plus initial value minus final value t power minus t by tau. Sound is low. Okay, 1 minute, I will check. Okay, voice is good? Voice is clear now? Sound is perfect, okay. Sound is perfect? Okay now. So then now here I am using the just first order response formula. Final value plus initial value minus final value into e power minus t by tau. How to find out the final value for this question? In t tends to infinite, we know the already t is equal to 0 plus, already Vc1 of 0 minus is given. So what is Vc1 of 0 plus is equal to how much? Vc1 of 0 plus is equal to 6 volts. Vc2 of 0 plus is equal to 24 volts. So what are t tends to infinite? These two capacitors are going to the open circuited, 18 volts. Here are 3 ohms and 6 ohms. So what a volt across 6 ohms is? The volt across 6 ohms is 18 into, I'm using voltage division rule, 18 into 6 by 6 plus 3. This value is 12 volts or not? Simply 12 volts. This 12 volts will be distributed across the two capacitors, but it's not a correct here now. But initial voltages are there. So whenever two capacitors connect in a series, so how to find out the Vc1 of infinite is? So Vc1 of infinite is equal to, just carefully look here now. Vc1 of infinite is equal to 12 volts minus initial voltage across the capacitor. How much voltage is here now? Minus 6 minus 24 initial voltage across the second capacitor into opposite capacitor 0.6 by 0.6 plus 0.3. This is a voltage division rule. This is the most important. So we are initial, there is no initial voltages across the capacitors, directly take as zeros. Plus here is adding a the 6 is the initial voltage. If you want Laplace transform use कर सकते. Without Laplace transform, how to find out the Vc1 of infinite? You use 12. Where is the 12 volts is? The volt across 6 ohms. 12 volts will be minus, why you are taking a minus 6? Here initial volt across the capacity C1 is minus 6 minus 24 into 0.6 by 0.6 plus 0.3. So how much this value is? Vc1 of infinite is equal to minus 30, 12 minus 30, that is a minus 18 into here 6 by 9, 9 ones are 9 twos the plus 6. This value is minus 6 is the final value. If you are not satisfied this procedure, you have to use Laplace transform technique. So what a time constant for this one is time constant tau is equal to R circuit R equivalent into C equivalent. So looking from capacitor, what R equivalent is, but inactive the voltage source, here 3 ohms and 6 ohms. Here R equivalent is 6 parallel with 3 is equal to 2 ohms. What about C equivalent? Looking from resistances, C equivalent is in a series, that is a 0.3 into 0.6 by 0.3 plus 0.6. This value is 0.2 for it. So I am using a now formula. V7 of t is equal to final value plus initial value minus final value to e power minus t by tau. Vc1 of t is equal to Vc1 of infinity is how much? Minus 6 plus, here Vc1 of 0 plus is plus 6, 6 of minus 6 e power minus t by tau. Tau is equal to RC. You have to 2 into 0.2, 0.4. So total after simplification minus 6 plus 12 e power minus 1 by 0.4 is 2.5, 2.5 t, t greater than or equal to 0. This option is correct. So option A is not a correct. Most of the members I think is given an answer as option A, but option B is correct. Vc1 of t is equal to minus 6 plus 12 e power minus 2.5 t. Just check it. Minus 6 plus 12 into e power minus 2.5 t. Ankit Karg is given a correct answer only. Final voltage 8 volts is not a correct. The final voltage is minus 6 volts. So there are two capacitors with initial conditions. How to apply the final value is this is a procedure for that. So without initial conditions, suppose initial conditions are not there, no initial charge on the capacitors, directly use kar sakte. You are given a whatever the 8 is the correct answer, no doubt, without initial conditions. If it is initial conditions are there, this is a procedure for finding the final value. Is it clear now? Shall I move to second question? No response. If you suppose you are facing any problem with this method, you can apply Laplace transform technique, very easy, but it is a lengthy process. Now question number 2. In the circuit shown in which V in of t is equal to 5 u of t, Vc1 of 0 minus is equal to 3 volts, Vc2 of 0 minus 0 volts, IL of 0 minus 2 amperes, the voltage V0 of t at t is equal to 1 second. The circuit consists of here R, L and C. So whenever the circuit consists of R, L, C, if you want the response of the circuit, always here preference is given to the Laplace transform technique. Time domain may it will take a more and more time. So in place of time domain, you would use Laplace transform technique, you'll get an answer now. Come on fast. Very simple question, just directly apply Laplace transform technique. So now start the discussion now. Vc1 of 0 minus is equal to how much? 3 volts. Vc2 of 0 minus is equal to 0 volts and IL of 0 minus is equal to 2 amperes. How to replace capacitor? The capacitor is replaced by voltage source in series with capacitor in a Laplace transform. The voltage source value is 3 by S and this is 1 by S. Now inductor is replaced by voltage source. The voltage source direction same as current direction. The value is L into I naught in series with inductor. Here L value is 0.5, I naught is 2. So this value is 1. Ls is 0.5 S. Here no initial conditions. So directly you can replace with a capacitor, that is the 1 by S. Okay. Now I am applying a Laplace transform now here. volts, here is a 5 by S. Capacitor is replaced by plus minus 3 by S in series with a 1 by S. Another capacitor is 1 by S only. Inductor is replaced by voltage source in series with inductor. Resistance is a resistance. After applying a Laplace transform, this is circuit diagram. This value is 1. This inductor value is 0.5 S and resistance value is 1 ohm. V output of S. Come on. I am simply using a source transformation technique here now. 5 by S, 3 by S. Minus to plus, minus to plus. Oppose. This total value is 2 by S. 2 by S volts in series with the 1 by S. Now convert a current source. The current source value is 2 by S by 1 by S. It is the 2 in parallel with 1 by S in parallel with 1 by S. Up to this 1 by S is 1 by 2S. So it becomes a 1 by 2S, 2 amperes. Again convert a voltage source. This value becomes 2 into 1 by 2 plus minus 2 to get cancelled, 2 into 1 by 2. This value, voltage source value is 2 into 1 by 2S. 2 to get cancelled, the value is 1 by S in series with 1 by 2S. Up to this, the circuit becomes 1 by S in series with 1 by 2S. Now connect in series with S. plus minus 1 by S in series with 1 by 2S series minus to plus inductor and resistance. No one has given an answer up to now. कोई भी नहीं दिए आंसर. 1 0.5 S and 1 ohm. Now V output of S. I am directly using a voltage division rule is here. V output of S is equal to 1 by S plus 1. 1 by S plus 1 is the total voltage into where you want the voltage 1 ohm upon 1 by 2 S plus 0.5 S plus 1. So V output of S is equal to S plus 1 by S upon 2S into 0.5 S square 2S plus 1 by 2S. S's get cancelled. 2 is going to the numerator. This value is 2 into S plus 1 by S square plus 2S plus 1. So V output of S is equal to simply 2 into S plus 1 by S plus 1 whole square or not? S square plus 2S plus 1, it becomes S plus 1 whole square. So square S plus 1 get cancelled. So V output of T is equal, directly apply inverse Laplace transform to this one, 2 into e power minus T, T greater than or equal to 0. Now the question is, at T is equal 1 second, what is the value of V naught? The volt across 1 ohm क्या हो सकता है? So V naught of 1 second, 2 into e power minus 1. So 0.368 e to the power minus 2 into 0.368 or 3679, 368, it becomes 0.735 volts is the answer. How many of you given a same answer? Only 1, 2, 3. Only 3 people. 4. Only 4 students are given answer is 0.738 or 735. So whenever the circuit consists of RLC, so indirectly you have to apply, directly apply use the Laplace transform technique. So capacitor is replaced by voltage source with capacitor, inductor is replaced by voltage source with the inductor. Okay, is it clear now? No response. Come on students. No response. थक गए क्या? Patience खत्म हो गया क्या? How is the question? Is a good question, array? Shall I move to next question? Right. Now third question is, carefully read. Pehle, you have to read the, please read the question carefully. Take a screenshot. Screenshot ले लो. Give answer within 2 minutes of time. It will take only 40 minutes. Within 40 minutes, I will cover the 10 questions. So, transient analysis, two-port networks and magnetic coupled circuits. So, 11 questions total. So, already 2 questions are over, only 9 questions remaining. So, please give a response fast, then close the session. Okay. So, in this question, what is the question is here? In a given circuit, after the circuit has reached a steady state, the switch S closed and automatically reopens permanently when the current through it becomes 0. So, when the current through this branch is 0, then it will open. So, for how long the switch remains closed? कब open होता है? कब open होता है? Already given the statement is when the current is 0, then it will open. So, how much time will take to open this switch? So, how to start here now? When our inductor and capacitor are present, LC means second order. Second order means always apply Laplace transform technique directly, blindly apply Laplace transform technique. So, whenever applying a Laplace transform technique, so first find out initial conditions. So, t is equal to 0 minus, switch was opened. Now, inductor is connected to the source, inductor with source, that is short circuited. Capacitor is connected to the source with source, it is a open circuited. Now, inductor is replaced by short, capacitor is replaced by open. The circuit diagram, this is t is equal to 0 minus 300 volts. So, what a volt across capacitor is? Vc1 of 0 minus is equal to 300 volts. Vc1 0 minus is equal to 300 volts. What about IL of 0 minus is? 0, open circuited, IL of 0 minus is 0. Now, apply Laplace transform to this circuit. Inductor is replaced by inductor, capacitor is replaced by voltage source in series with capacitor. Now, after reaching the steady state, the switch is closed, resistance 300 volts, this is a 3K, t greater than 0, this is the value of inductor is how much? 1 millihenry, that is 1 into 10 to the power of minus 3 into S in Laplace transform. V0 by S, 300 by S, capacity is 1 by 0.001, 0.001, 001 micro to S. So, this value becomes 10 to the power of 9 by S. A current क्या होना चाहिए 0 amperes के लिए. This current is suppose I1, this current is I2. I1 plus I2 is equal to क्या होना चाहिए 0 होना चाहिए. I1 plus I2 is equal to 0. That means I2 is equal to minus I1. What is I1 is equal to? I1 is equal to 300 by 3K. 300 by 3K. This value is 0.1 amperes. I1 is 0.1 amperes. So, at what value of time the I2 is equal to minus 0.1 amperes? That is the time. How to find I2 of S? I2 of S is equal to I2 of S is equal to 300 by S upon 1 into 10 to the power of minus 3 into S plus 10 to the power of 9 by S. So 300 by s, s's get cancelled, 10 to the power of minus 3 s square plus 10 to the power of 9, take a 10 to the power of minus 3 is common, so 300 into 10 to the power of ऊपर जाने के बाद 10 to the power of 3 by s square plus 10 to the power of 12. This is I2 of s. I2 of s is equal to, it becomes 300 into 10 to the power of, I can write 0.3 into 10 to the power of 6 upon s square plus 10 to the power of 6 whole square. This is just like a omega by s square plus omega square. So what is I2 of t is equal to? I2 of t is equal to 0.3 sine 10 to the power of 60 in time domain, 0.3 sine 10 to the power of 60. This value is equal to I2 is equal to minus I1. Minus I1 is minus 0.1. At what time of t the value of the current is minus 0.1. So minus 0.1 is equal to 0.3 into sine 10 to the power of 60. So sine 10 to the power of 60 is equal to minus 0.1 by 0.3, 1 by 3. So 10 to the power of 60 is equal to sine inverse of minus 0.1 by 3. 1 by 3 only, not 0.1 by 3, 1 by 3. 1 by 3. We'll get a value is, most of the members are doing the mistake here. Get a minus 19 point something 47. 19.47 will get. The time always is a positive, but getting a negative. So minus 19.47 also equal to, this is the most important step is here. Then 19.47 is the degrees. Sine of minus theta is equal to minus sine theta. So this value also equal to 199.47. Sine of minus 19.47 also equal to sine of 199.47. Just check it. Sine 225, you will get a sine 180 plus 45 degrees. Sine minus 45 and sine 225 both are same. Same just like here is, this value must be positive होना चाहिए. Why? Because t must be positive. So at what value? Same value, sine inverse of minus 1 by 3 is also equal to 199.47. Just check it in your calci. Sine of minus 19.47 value and sine of 199.47 values are both are same. This is in degrees. It cannot be a radians into pi by 180. So t becomes, so 199.47 into pi by 180 by 10 to the power of 6. So you will get a t is equal to 3.48 microseconds. Just check it. T is equal to 3.48 microseconds. How many of you know 0.34 microseconds is not a correct answer? Robins Kumar. Oh, Ajay Kumar is given a correct answer 3.48. Geeta Rani is given a correct answer 3.48. And Secret Lovers 3.48. Aditya Prasad also given a correct answer 3.48. So option is there or not? Check it. 3.48 option is there. Yes, option A is correct. Option B is correct. Option B is correct. 3.48 microsecond. Okay, how is the question? Give a question rating is 5 for 5 out of 5. How many marks for this one? So next question. Please read carefully. Take a screenshot. In the circuit shown, one fuse is designed to open. This is a fuse. When the power absorbed by R, which one is R? This is a 1 ohm, exceeds the 10 watts for 0.5 seconds. The input is given by Vs of t is equal to A u of t minus A u of t minus 0.75. The largest value of A that will not cause fuse to open. So 10 watts के ज़्यादा नहीं होना चाहिए. Please give answer now. शर्मा जी, आपको पूरा ये वीडियो मिल सकते हैं डायरेक्टली, सो पीडीएफ का जरूरत नहीं है मे बी. Come on students, give answer now fast. Here is no options. It's a numerical data question. Simply this is RL circuit, first order circuit only. So what the input is? Input is a pulse A u of t minus 0, this is A, this is 0.75. कब तक स्टैंड होता है? और एक्सीड्स 10 वॉट्स फॉर 0.57 तक, 0.57 सेकंड्स तक विथस्टैंड होता है. और मीन्स फ्यूज. सो 0.5 मीन्स 0.75 से you have to minus it 0.525 से. So our aim is to find out in between 0.25 से 0.75 इसके बीच में 10 वाट्स के ज़्यादा. सो 0.25 के टाइम पर भी 10 वाट्स के कम होना चाहिए. If it's greater than 10 watts, fuse open होता है. So जिस लेके RL circuit है, this is you are given a pulse. Our interest is only up to this 0 to 0.75. After 0.7 I don't want. So up to 0.75 the response is a exponentially increasing or not? After 0.75 it will be decreasing because of your input is going to 0. So in the step signal, so what is the IL of t? Directly you can write IL of t is without IL of t is equal to IL of 0 minus is equal to 0. IL of 0 plus also 0. What about IL of infinite? T tends to infinite. T tends to infinite. IL of infinite becomes short circuited. The total current is A by amplitude by resistance is 2 plus 1 3, A by 3. What a time constant? Tau is equal to L by R. L is equal to 0.2, R is equal to 3. Resistance 2 ohms and plus 1 ohm. 0.2 by 3. Now apply the formula. IL of t is equal to final value plus initial value minus final value into e power minus t by tau. IL of t is equal to, IL of infinite is how much? A by 3 plus 0 minus a by 3 e power minus t by tau 0.2 by 3. Yes, 0.2 by 3. Now the value is IL of t is equal to a by 3 is take a common 1 minus e power minus 3 by 0.2, that is 30 minus 15t. This is IL of t. A t is equal 0.25, 0.5 सेकंड तक विथस्टैंड होता है, इसलिए 0.75 से your 0.5 you have to subtract it. So find out IL of 0.25 value. At t is equal to 0.25, a by 3 into 1 minus e power minus 15 into t, t is equal to 0.25. This is a current value. Power do not exceed the 10 watts, that means IL square into R fuse is not greater than 10 watts. Duration 0.25 to 0.75. A duration. Duration is not this, is duration is 0.5 seconds, that means 0.25 to 0.75. So RF is equal to 1 ohm. So IL square a by 3 into 1 minus e power minus 15 into 0.25 whole square into R is equal to 1 is equal to 10 watts. इसके ज़्यादा होना चाहिए, नहीं होना चाहिए, is equal to 10 watts. So after simplification, square going to that side is a root, and a value becomes nearly 9.754. 9.754, 715 maybe, 7154. Oh, how many of you given a same correct answer? 9.71. Gautam Rana is correct. Ahan Basu 9.71. Shruti Jain, Aditya Prasad. Why are you taking 0.25? 0.25 से 0.5 सेकंड तक विथस्टैंड होता है, इसलिए 0.25 से so it becomes क्या होना चाहिए, 10 watts के इक्वल होना चाहिए, अदरवाइज इट विल फेज विल बी ओपन. 0.57 तक 0.5 का टाइम पीरियड दिया ना, इसलिए यू टेकन 0.25 ईयर. Why 0.5? No, 0.5. The withstand capability is 0.5. 0.75 से you subtract 0.5. So let me move to third question. For fifth question. Now this last question is based on transient analysis maybe. The switch is open at t is equal to 0 if the value of capacity is such that the current through the branches is transient free, then the value of capacitance in microfarad. So what is the current is flowing through the 1 kilo ohm is a transient free. There is no transients, directly it reaches the steady state. The same, the current flowing through this branch also a transient free. That means within 0 seconds it reaches the steady state. There is no e power minus t by tau term. So what is the answer is? Take a 2 minutes of time. So give answer now. The question is visible? Question is visible? No response from the students. Come on. थक गए क्या का? 3 घंटे में तो थक नहीं होना चाहिए. Only Aditya Prasad Sahu who is given response. Ahan Basu 4.25. 4 microfarad. Yes, 4 microfarad is the correct answer. So very simple is here now. The condition for a transient free in this case is R1 C1 is equal to R2 C2. Then it becomes a transient free. आप भी देख सकते हैं. You can use the Laplace transform technique in this. Response is independent of time constant. R1 C1, suppose this is 1 kilo ohm, 1K into C is equal to 4K into C, 1 microfarad. So C is equal to 4 microfarad. The answer is 4. Other than R1 C1 is not equal to R2 C2, in the response it consists of transient term. So whenever R1 C1 is equal to R2 C2, there is no transient term. फिर आप check कर सकते. Okay. Next is moving to the 2-port networks problem. So very simple question. Directly बोल सकते, देख के बोल सकते. Very simple question. कभी कभी simple questions भी देते हैं गेट में. I think it is visible. Come on guys, come on students, give answer for this. B is answer. Vishal Baba, Ahan Basu. Sai Vishnu also given a B answer. ये आदित्य प्रसाद साहू ये क्या देखेंगे ना. नॉर्मली इसे सीरीज कनेक्शन बोलते हैं नॉर्मली, बट इज नॉट ए करेक्ट. फॉर सीरीज कनेक्शन दिस मस्ट बी ग्राउंडेड, दिस आल्सो ए ग्राउंडेड. सो मोस्ट ऑफ द मेंबर्स आर डू द मिस्टेक हियर. नॉर्मली क्या करते हैं, ZA प्लस ZB. सो हियर इज 2 1 1 2 करते. For this also A, here is a 7 1 no 7 6 plus 1 plus 1 8 करते. 8 1 1 and 3 plus 1 plus 4 plus 1 5. So 2 8s are 10. 1 plus 1 is 2. 1 plus 1 is 2. 5 plus 2 is 7. It is not a correct. It is not a correct. When it is correct, if 6 ohms प्लेस में 0 ohms होना चाहिए, 3 ohms के प्लेस में 0 ohms होना चाहिए, then only it is called as a series connection. समझ में आ गया क्या नहीं है? This is called series connection. एलिमेंट नहीं होना चाहिए इधर. no element. So this is called a series connection. A series connection nahi hai. So in this case, how to do? This point is same. So 6 ohms, 3 ohms are in parallel or not? 6 and 3 are in parallel. So don't do the ZA plus ZB here. So normal simplification, 6 ohms, 3 ohms are in parallel. So that becomes, the circuit becomes 1 ohm, 1 ohm, 1 ohm, 6, 3 in parallel, it becomes a 2 ohms. And again 1 ohm is in series. Here 1 ohm and here 1 ohm. Now simple T network, equivalent T network, directly you can say Z is equal to 1 plus 1 plus 2, 4, 5, 6. 1 plus 2 plus 1, 4, 4 and 1 plus 2, 4, 5, 6. 6, 4, 4, 6. 6, 4, 4, 6 is the answer for this question. B is a correct option for this. A is not a correct option. B is a correct option. Dear students, is it clear now? The concept is what is series connection. So when series connection लेना तो इधर elements ना रहना चाहिए. There's no elements between this. So next question. The given circuit of figure, H parameters are given. 45, 0.8, minus 0.5, 0.01. For the two-port network, the VI characteristics, it is not a characteristics, VI characteristics, so VI characteristics of nonlinear load is given by 48I minus 4I square. The average power delivered to the nonlinear load is, this is a nonlinear load, it's a load. Here given V and I relation is given, this VI relation is given, this H parameters are given. So find out how much power absorbed by the nonlinear load. So take a 2 minutes of time. So H parameters are given, this total network is replaced by up to this VTH Thevenin voltage Thevenin resistance में replace कर सकते हैं, very simple, using H parameters. The open circuit the 2 dash port, find out the VTH. Using the V by I ratio, find out the RTH. H parameters V1 is equal to, is given information is V1 is equal to 45 I1 plus 0.8 V2, I2 is equal to minus 0.5 I1 plus 0.01 V2. Find out VTH. Now find the VTH, open circuit the I2. Open circuit means I2 is equal to, I2 becomes 0 amperes. What do we would V1? V1 is equal to, you can write KVL equation in this loop. KVL equation is the loop. 80 minus 15 I1 is equal to V1. Equation 1, equation 2. V1 place में, in place of V1, 80 minus 15 I1 is equal to V1. Just substitute here now. 80 minus 15 I1 is equal to 45 I1 plus 0.8 V2. Our interest is, our intention is, find out the V2. V2 nothing but a VTH here now. After open circuited, I2 becomes 0. Here is the volt across, here is a V2. 80 minus I1 is equal to 80 minus 0.8 V2 by 60 is I1 value. Just substitute here now. So I2 is equal to 0 minus 0.5 I1 in place of I1, 80 minus 0.8 V2 by 60 plus 0.01 V2. Just simplify it. Minus 0.60 here now. 0 is equal to minus 0.5 into 80. Minus into minus is plus. 0.5 into 0.8 is becoming 0.4 V2. 60 into 0.01 is 0.6 V2. This value is 40. So V2 is equal to how much? 40 volts. So VTH becomes 40 volts. VTH आ गया 40 volts. Output RTH. So direct formula also there. Y out. So these are most important formulas. Very easy to memorize. Z in, Z out, Y in, Y out. What is H22 is? H22 is a Siemens. H22 is I2 by V2. So here is H parameters. Voltage is replaced by short circuit 15 ohms, a plus or minus V1. This is I1. You connect voltage source here, V and I. I2, this is a V2. V is equal to V2, I is equal to I2. So find out V2 by I2 ratio. That will give us the RTH. But we know the formula for this. Y out. What a Y out is? Otherwise you can use direct V2 by I2. Otherwise use direct formula. याद में तो direct formula use करो. Otherwise V2 by I2 derive करो. Y out is equal to H22 minus H12 H21 by H11 plus RS. R1 means Z parameters में, Y parameters में ये same है. If it is Z out in a Z parameters, a Z22, a Z12, Z21 by Z11 plus RS. RS means internal resistance of the source. इन y पैरामीटर्स में y out y22 minus y12 y21 by y11 plus rs नहीं है, here is y11 plus rs के प्लेस में 1 by rs लिखना पड़ता है, because rs in ohms, y11 in a Siemens, so इसलिए 1 by rs लिखना पड़ता है, ये याद में रखना है. So y out become y out is equal to h22, and h22 value is 0.01 minus h12 and h21 is minus 0.5 into 0.8 by 45 plus internal distance of the source is 15. We get a y out, 1 by y out, RTH is equal to 1 by y out. So after simplification we will get a 60 ohms, just check it, a 60 ohms. So you get a RTH and VTH. Now connect the load. So VTH is 40 volts, RTH is 60 ohms. Now the nonlinear load is, this is a nonlinear load, is a V, this is I is given, information is V is equal to 48 I minus 4 I square. Now write a KVL equation, KVL is applicable to the nonlinear also. 40 minus 60 I minus V is equal to 0. So 40 minus 60 I minus V, 48 I and 4 I square is equal to 0. This is a quadratic equation. Solve the quadratic equation. Get a I is equal to 26.67 or 0.375. Check it, please check. So which one is the correct now? 26.67 or 0.375. 26.67 is not a correct. Why? Because if you are substituting this 26.67, V is becomes a negative. V negative means it acts as a source, but in a question is given this is a load, it is not a source. So 26.67 is not a correct answer. The answer is 0.375 ampere is a correct. So now what the power is? Power P is equal to V into I. P is equal to V into I. What a voltage? V is equal to 48 I minus 4 I square. V is equal to 48 into 0.375 minus 4 into 0.375 whole square. Okay, so we are getting a 17.34 something. So P is equal to V into I, 17.3475 into 0.375. So nearly equal to 6.54 something, 16 point, check it, 6.54 watts. The answer is 6.54 watts. How many of you given the same answer? Gautam Rana is given a correct answer 6.53. Ahan Basu 6.54. Only 2 members. Aditya Prasad Sahu, can we say that Z22 is a RTH? No, no, no. Z22 is not a RTH. Whenever the terminated with a load, Z22 is not a RTH. Terminated with a load, it is not a RTH. क्या पूछ रहे हैं अमन कुमार सिंह जी? Y out formula, Z in, Y in, Y out formula is very easy. Z पैरामीटर्स के लिए, Y पैरामीटर्स के लिए, H पैरामीटर्स के लिए डायरेक्टली लिख सकते. Z in, Y in. Just look here now. For Z parameters, for Z parameters, the load is terminated with any, the two port network, 2 dash port is terminated with load, Zin is equal to Z11 minus Z12 Z22 by Z12 Z21 by Z22 plus ZL. This is Z in for Z parameters. It is terminated with a load. What about Z out? Z out is equal to Z22, उधर से देख रहे हैं ना, Z22 minus Z12 Z21 by Z11 plus ZS. ZS is the source impedance. So Y in, Y parameters में Y in, same, no change. Only the change is Y11 minus Y12 Y21 by Y22. Y22 सीमेंस में है, लोड में भी सीमेंस में होना चाहिए, इसलिए क्या लिखना है 1 by ZL लिखो. Y out will be same, Y11 plus 1 by YS. बस simple. Okay. So let's move to next question. No response, only 2 or 3 members are giving the answers. ये difficult है क्या? Simple है ना? So non-linear load में apply कर सकते हैं ना Thevenins? Yes, load is non-linear, Thevenins apply कर सकते हैं. Very simple question this is. For given circuit, the transmission parameters. Options भी दिए. This value is 2V2, 2V1, 1 ohm, 1 ohm, 1 by 2 ohms. Give answer now fast. Aditya Prasad ji, when we are calculating the V2 by I2, V2 by Z22 is V2 by I2 providing I1 is equal to 0. I1 is equal V2 by I2, I1 is equal to 0, then only Z22 will comes. RTH is different, V2 by I2 only, not I1 is equal to 0. You are not studied whenever the load, whenever 2 dash port is terminated with a load, then how to calculate RTH? But answer for this question. First, this is a 2V2. This value is 2V2. Visible? Okay. Come on student, come on dear students. Look here now. So first don't find out the transmission parameter directly here now. So for this circuit देखने के बाद आपको मालूम होना चाहिए which parameters are suitable for this circuit. So now this is suitable for Y parameters. Why? Because this is now node 1 and node 2. So KCL is simple for parallel circuit. KCL means I1. I1 is equal क्या है? Y parameter. So find out Y parameters first for this network. So ABCD parameters नहीं करना है, Y parameters लेना है. This is V1, this is V2. Now apply KCL here. Now I1 is entering current, 2V2 also entering current is equal to outgoing currents are V1 by 1 plus V1 plus 2V1 minus V2 by 1. ये आ गया I1 is equal to V1, 2V1, 4V1, 2V2 is minus 3V2, equation 1. Second equation, write a KCL equation here. I2 is entering current, outgoing currents are V2 by 1 by 2, there is a 2 V2 plus V2 minus 2 V1 minus V1 by 1. So I2 is equal to how much? Minus 3 V1 and plus 3 V2. This is a second equation. From this you get a y parameters. I1 is equal to 4 V1 minus 3 V2. I2 is equal to 3 V1 minus 3 V2. Once you get a y parameters, how to find the transmission parameters? You write a now transmission parameters equation. V1 is equal to A V2 minus B I2. I1 is equal to C V2 minus D I2. So here compare now. I1 compare. I1 V2 is there. I2 in place of I2 here is a V1 is there. So replace V1 को replace करना है. कैसे replace करना है? Write a V1 from this. But V1 is equal to, here is, look here now, is correct, minus 3 V1, minus 3 1 this is, just, this value is minus 3 V1, this is a plus 3 V2. So V1 is equal to, here V2, 3 by 3 is V2, so minus 1 by 3 V1, 1 by 3 I2. V2 minus 1 by 3 I2. Now substitute in this first equation. I1 is equal to 4 into V1 is V2 minus 1 by 3 I2 minus 3 V2. So I1 is equal to 4 V2 minus 3 V2. V2 minus 4 by 3 I2. हो गया, I1 इक्वेशन आ गया, V1 इक्वेशन आ गया. Compare with the equations. Now becomes 1 by 3, 1 and 4 by 3. This is option. Option में है क्या? 1 by 3, 1 4 by 3. Option A is correct. Is it clear now? So for given question देखने के बाद directly transmission parameters find out नहीं करना है. It will take a more and more time. In place of transmission parameters, first find out y parameters, then find out the transmission parameters. This is the last question. So based on two-port network, consider the resistive linear. Consider the resistive linear. Time invariant two-port network shown in figure. It is given that V1 of t is equal to 30t, V2 of t is equal to 0, I1 of t is equal to 5t amperes, I2 of t is equal to 2t amperes. If V1 of t is equal to 30t plus 60, V2 of t is equal to 60t plus 15, then value of I1 of t. You answer fast. B is not a correct answer. What information is given? V1, V2. V2 is equal to 0 means short circuited 2 to dash port. So short circuit parameters are y parameters find out कर सकते. You can write I1 is equal to y11 V1 plus y12 V2. A resistive network means resistive always a reciprocal network. So y12 is also equal to y21. From given information, V1 is there and I1 is there. V2 is equal to 0. Y11 is equal to I1 by V1 provided V2 is equal to 0. So I1 is 5t upon 30t. I2 direction is here only, not in this direction. So what the value of 5 1s are 5 6 are. So 1 by 6 is the y11. y11 आ गया 1 by 6. Next y12. y12 is nothing but y21. y21 is equal to I2 by V1 provided V2 is equal to 0. What V2 is? I2 is 2t. 2t by V1 is how much? 30t. That is 1 by 15. y12 and y21 both are same. So y12 is equal to a लिख सकते 1 by 15. Now I1 is equal to y11 v1 plus y12 v2. I1 is equal to y11 is, how much y11 is? 1 by 6 into v1 is how much? v1 is equal to 30t plus 60 plus y12 is 1 by 15 into 60t plus 15. So I1 is equal to 5t plus 10, 4t plus 1. I1 is equal to 90 plus 11 is the correct answer. 90 plus 11. 90 plus 11. A is the correct answer. Only Ajay Kumar is given the A option. Abhi there A option. If your I2 direction is opposite, then t plus 9 is the correct answer. I2 direction is opposite, then t plus 9 is the correct answer. Now the question is based on magnetically coupled circuit. Figure shows a simplified model of an ideal amplifier containing an ideal transformer. The input voltage is at 2 kHz with a magnitude of 1 volt. 1 volt hai. The load is loudspeaker represented by 4 ohm resistance. This is a 4 ohm resistance, the loudspeaker. This is a model of an amplifier. If the turns ratio A value such that the maximum power delivered to the load, the value of maximum power. Maximum power क्या होना चाहिए? What a condition for maximum power? This is now source resistance and load resistance must be equal होना चाहिए. So what is the value of A? This is A is to 1. This given is information is A value. A value find out कर सकते हैं. There no need to find out the A value also. A value such that the maximum power delivered to the load. So directly you can 4 ohms becomes क्या होना चाहिए? 900 ohms होना चाहिए. So A value क्या हो सकते हैं? 15 होना चाहिए. Directly बोल सकते हैं A value 15 है तो this 4 ohms becomes 900 ohms होता है. So what is the maximum power transformation directly? Without VTH directly बोल सकते हैं VTH is equal to 200 VN. VN is 1 volt or not? So 200 volts. This is a VRMS only. What about the RTH? RTH is equal to 900 ohms only. Directly RTH is 900 ohms. So what is the formula for power? P is equal to VTH square by 4 RTH. So P is equal to VTH square is a 200 into 200 by 4 into 900. This give a answer now. You want A value find out करने के suppose A value find out करने के लिए क्या कर सकते हैं? How to find out A value is? You want A value. If ask A value also, A value के लिए simple is 900 is equal to 4 by K square. K is equal to how much? K is equal to 1 by A. So whenever second to primary you divide, so 4 by k square, this is 900 is equal to 4 by 1 by a square, this is a square, it becomes a square is equal to 900 by 4. If asked the question is a is equal to how much here now? 15. A is equal to 15, if asked the question is a, but here is only power is equal to VT square 4 is a direct formula for maximum power transformation. more resistive circuit में directly use कर सकते हैं VTH square by 4 RTH. It becomes a I think 11.11. The value is P is equal to 11.11 watts. Okay, is given. Oh, more number of people. Only 3 members are given. Correct answer now. A is equal to 15 is given. Okay, last question. Now give answer for this question. The frequency at which the current I in circuit is the same magnitude when the connections of one coil are reversed. The frequency of the circuit in radian per second is. Come on, fast. Anyone is there or not? Mr. Aditya? Ahan Basu? The question तो समझ में आ गया ना? The question is clear? Okay, no give answer now fast, come on. Gautam Rano. Right, look here now. The current in both the cases must be same होना चाहिए. I is equal to, what is the current I is equal to in this case? V by either XL minus XC or V by XC minus XL. L may be a, L equivalent is L1 plus L2 plus 2M, magnetically coupled here now. Once reverse means L is equal to L1 plus L2 minus 2M. So when both are equal हो सकता है, देख लो here is L equivalent is equal to L1 plus L2 plus R minus 2M. Minus for reverse. One is addition, one is a subtraction, means reverse होने के बाद minus 2 बता. So minus 2m means whenever minus 2m XC value is greater than XL value होना चाहिए पक्का. Otherwise both are not equal. So XL equivalent to is equal to how much? XL1 plus XL2 plus R minus 2XM. So both are equal means V by XL minus XC, in this case XL is greater than XC. That means this is a additive polarity is equal to V by XC minus XL. After reversing the coil, this is XL. I call it S. So V we get cancelled. This XL minus XLA minus XLC is equal to XC minus XLS. XLA is nothing but a addition. That value is XL1 plus XL2 plus 2XM minus XC is equal to XC minus XLS. XL1 plus XL2 minus 2XM, ये रिवर्स होने के बाद अभी देख लो ना, here is minus XL1 is coming to here now, 2XL1 2XL2 2XM get cancelled, so here is 2XC XX2XC, 2 get cancelled, XL1 plus XL2 is equal to XC. What is XL1 is omega is common करो, L1 plus L2 लिख सकते डायरेक्टली, L1 plus L2 is equal to 1 by omega C. Omega square is equal to 1 by C into L1 plus L2. Omega is equal to 1 by root C into L1 plus L2. Substitute these values. C value is 6 microfarad and L1 plus L2 values are 30 and 120, that's 150. 150 milli root. So we get a, I think 1054 radians per second. This answer. Very good. 1054.09. Okay. Only Basu give an answer. Only Basu. Almost all types of try किए थे कवर करने के लिए. So transients we covered, RC circuit, RL circuit and RLC circuit and LC circuit. 4 RC, RL, RLC and LC circuit cover किए थे. In two-part network, Z parameters, Y parameters, H parameters, ABCD parameters. And magnetically coupled circuits is covered, is additive polarity and also a opposite dot connection is reversed, and also covered here is maximum power transformation theorem whenever the circuit consists of transformer. Okay. So all the best. Please go through the whatever the short notes already given to you, already provided. So last में है, so there are only 4 types of questions in our GATE examination always, is a memory based or formula based, analytical based and thought provoking questions रहते हैं. सभी नया concepts के लिए पढ़ना नहीं, so previous whatever the concepts आपका mind में है, एक concepts को revise करो, thoroughly revise करो. So don't do the silly mistake in examinations. So ये कम करने के लिए ज़्यादा practice करना पड़ता है. So all the best for your GATE and IAS exam के लिए. Any questions, any queries, please comment on the comment box. So how is the questions also give a comment कर सकते हैं. Okay, the next time will be useful for me for improvement के लिए. Okay, thank you a lot. धन्यवाद, बहुत बहुत धन्यवाद. आपके अभी तक 3 घंटे से आप पेशेंसी और एंड ऑल्सो ये रेस्पॉन्स देना तो मुश्किल है, फिर भी आप दे रहे, सो इसके लिए थैंक यू, धन्यवाद, बहुत बहुत धन्यवाद.